All right, hi everyone. Today I'm excited to speed run through safety-first cognitive architectures. My name is Brendon Wong. I'm a tech and social entrepreneur. I'm also a product manager. I've worked in the AI, big data, and software spaces, and I'm also the founder of Cosmic, which is a startup that's working on cognitive architectures and also some of the interesting technologies at the intersection of this, including neurosymbolic AI, collective intelligence, and knowledge management. I'm happy to chat about any of these or the intersection of them. If you're interested, come find me. So I'm hoping to cover three things very quickly today. What is a cognitive architecture? What is a safety-first cognitive architecture, and what's kind of going on in the broader landscape? And what areas of safety-first cognitive architectures do I think pertain to security? So a cognitive architecture, I define it as a set of specialized interlinked systems that act intelligently as a whole. And if you look at the Wikipedia definition, this can actually refer both to a theory about the structure of the human mind, as well as how this can apply to a digital brain as well. So for example, on the right here, this is the ACT-R cognitive architecture developed in the latter part of the 20th century. And it kind of has a bunch of different systems. There's a procedural system here that's kind of deciding what to do, and it's coordinating a bunch of other systems. It's like fetching relevant parts from memory where needed to achieve goals. And in this picture, the ACT-R framework is being mapped to different parts of the human mind, like, for example, the prefrontal cortex for goal setting and coordination. However, of course, in the context of this conference, the systems I'm going to be talking about are not sort of parts of the human mind or neurons, but actually different AI models or different instances of the same AI model, like GPT. Could be automated systems like a database, and it could also be humans can also contribute to different parts of a cognitive architecture to produce intelligent work. On the right here, we have, this is essentially just AutoGPT, and you can see that it actually has some similar components to the ACT-R sort of cognitive architecture. You can kind of see most of the middle part of the systems around deciding what to do, so kind of like the procedural coordination part in the previous image. You can see it also has a memory system, has a system to specify the goal. So pretty similar, lots of relations, of course, between how the human mind works and how a digital mind might work if it's formed of different components performing different functions. And so what is the safety-first cognitive architecture? Well, as the name sort of implies, it's a cognitive architecture designed with AI safety in mind. Here, I'm going to aim to quickly share some intuitions around why I expect that cognitive architectures would be a promising direction in terms of AI safety. So it's true, a cognitive architecture is kind of intelligent and an agent in the same sense that a company or organization is intelligent and an agent. And a company and organization can certainly act in intelligent and agent-like ways. It can achieve goals. It can produce novel cognitive output. But it isn't like intrinsically intelligent or agentful. It behaves in known and changeable ways. And I think a very close analogy is kind of like you're the CEO of, like, let's say, a company or an organization. You can specify the mission. And everyone in your company can only communicate via like a fully public Asana. So you can kind of have an understanding of what the system is going to do, why it's doing it, the actions it's going to take before it takes them. Everything's kind of transparent in that manner. In terms of how this actually works in most safety-first cognitive architectures, the goals, plans, intended actions, and reasoning of systems are fully interpretable and corrigible. They're orchestrated via usually either natural language or structured data. And if you actually change the natural language, or if you change the structured data itself, you're actually changing like the goals, the plans, and the actions of the system itself. And the different parts of the system are just taking those things as input. They have no idea that you've modified it. They're just taking it as input and doing additional knowledge work based on that. In terms of like what's actually going on in the safety-first cognitive architecture space, this is all of the safety-first architectures that I'm aware of, organized on a scale from most similar to AutoGPT on the left to least similar to AutoGPT on the right, kind of like a talk that Evan was giving earlier. So starting from the left, AutoGPT is a language model-based cognitive architecture. You can use LLMs, or you can use other sorts of systems in a cognitive architecture. So AutoGPT is, of course, only uses language models, and it's not a safety-first architecture, right? You got GPT kind of recursively calling itself. It's doing all sorts of weird things. There's like no control over exactly what it's doing. It can like do all sorts of terrible things, and some people have had this happen to them while trying to run AutoGPT. So starting off from the left there, Conjecture is a UK-based for-profit company. They're working on the cognitive emulations, or COEMs. There's not a lot of public information about it. Their CEO did do a talk, but essentially they've sort of popularized the concept of like boundedness, like having like compute-bounded human-level AI models running in parallel and/or rapid succession to do a lot of knowledge work. The idea is you're not really using super intelligent models that are unpredictable, but by using a lot of them, you can still get sort of super intelligent results, kind of like a human organization. And they're all communicating with each other, so there's a human readable chain of thought. You can see why the system is doing what it's doing, why it thinks what it thinks, how it arrives at certain conclusions and actions. Then Eric Drexler has proposed the open agency model, which kind of involves separating out the systems for goals, plans, and actions. And that's kind of the fundamental reason why it's safe. And he's also introducing the idea here of having humans easily stepping into a particular part of the cognitive architecture at any time, whether that's performing an action or proposing or reviewing a plan that, let's say, for example, an AI model has generated, which of course is not present in AutoGPT. Some of my work involves using a lot of structured data as part of the system, externalizing memory and reasoning, and separating it from AI models themselves, and a few other features. And then I would say that some of Darad's work with his open agency architecture is derived from Drexler's open agency model, but I would almost argue is an entirely separate system. The main safety feature, it does have a separation of goals, plans, and actions, but the main safety feature is a very detailed, essentially Adams-level simulation of the world that can formally verify the effects of plans proposed by a super intelligent planning system. This would be very safe, and is also very difficult to do. This is why it's this is also like kind of a rough axis of difficulty. Yes, 1 minute. Most of these things are, there's a lot of similarities between all the different safety-first cognitive architecture approaches, like using bounding the models in many different ways, lots of security implications. Some of the main differences between the proposals or how advanced the underlying AI models used are. In terms of the implications for security, the timer here, that principle of boundedness has a lot of relevant implications, including sandboxing, making sure models and AI models and other parts of the system don't influence other parts of the system, or for example, in terms of restricting the information and actions that an instance of an AI model can take. These principles of compartmentalization, making sure it only has access to enough information it needs to do whatever cognitive task it's doing. It doesn't know why it's doing it. It doesn't know what the other parts of the system are doing. These are some features that can affect safety, and some other stuff which I won't go into now. Thank you.
That was very well sped through. I think we have time probably for a question or two.
Questions? Yeah.
What do you see as the main? Thanks. What do you see as the main kind of risks and kind of solutions at the moment for preventing something that's built up of multiple simple components for actually just kind of glomming together and more or less forming the same kind of worrisome kind of larger entity that we were started caring about? Yeah,
I think that this the risks and solutions do very much depend on the exact proposed design of the cognitive architecture. For example, I think one of the differences was the underlying AI models used, right? So I think that if you have a very super intelligent model to use, then you need very advanced and robust security measures. For example, if you're using something that isn't even an LLM, a lot of the cognitive architectures do involve language models, and so I think that there's a lot of relevant things there, ensuring, for example, I think one of the security concerns is ensuring the language models aren't I don't know, maybe embedding secret messages either purposefully or inadvertently that are getting passed along, and stuff like that. But I think there's a lot of relevant considerations, depending on the intended design.
What's the challenge that you want people to solve?
Challenge, I think there's quite a lot of challenges here. One thing that I think is interesting to think about is do the safety measures we need in a cognitive architecture change as the underlying AI models become more powerful, and what would they look like? I think is an interesting question.
Do you want to write it down yourself?
Sure.
Okay, wonderful.
Will do. Thank you.
Thank you, Brendon.